Thank you for joining us here today for Precision Digital's presentation on the new and improved features of our PDW wireless products. Some of you may be familiar with these products already, as they are not a new product line overall. However, this presentation is really going to focus on the new features. So if you do know it, that's perfectly fine. Now, I will spend some time going over the core of what the product is. So if you have never seen them before, that is okay. But if you are familiar with it, this is still a good place for you to be. Before I go ahead and get started with the content, there's a couple of questions that always come up, and I like to address those right away. The first one, which you've probably already noticed, is that you are in listen-only mode. That means that you can't actually talk during the webinar on audio, but you can send me questions. You can use the Zoom chat if you have things you'd like me to address during the presentation. So if you'd like to send me a question or have me address something, either send it in via the chat bar, which is integrated in your Zoom toolbar, or you can send it in as an actual question with the question submission tool. Now, that having been said, the second most common question I get, there's really a two-parter here, is can I get the slides, and is this presentation going to be available afterwards for me to watch? And the answer to both of those questions is yes. After this presentation is done, probably by the end of this week, you're going to get an email that's going to contain the slides from today's presentation as a PDF, and you're going to get a recording of today's presentation on YouTube. So you can look or review those yourself or send them along to anybody who you may know that you think could benefit from this content. The last administrative point I'll make here is that you would be doing me a personal favor here if you could fill out the survey at the end of today's presentation. Those survey results are really helpful in helping us decide what presentations to put on, how I'm doing as a presenter. If there's anything you can think of that you'd like to see from a content or from a presentation style standpoint, please give me that feedback because it is extremely useful to us. You should see that pop up at the end of today's presentation. So if you do, take 1 minute and fill it out for me. With that, we're going to go ahead and jump into today's content and talk about the new and improved features on the PDW wireless products. My name is Joe Ryan. I'm the VP of Sales and Marketing at Precision Digital. I'll be giving today's presentation, obviously. I've been in the process industry for almost 20 years now. I have been a product designer, a marketing manager, sales. Now I'm VP of Sales and Marketing. So I've seen a lot of different angles on these kinds of products and these kinds of applications. Puts me in a unique position to talk about them from both the technical side of things, but also what I've seen in the field that I think your customers or you would like to know about. The agenda for today is that we want to obviously introduce these new products and talk about the features that we've added to the wireless product line. But we also want to give a brief overview of what the PDW30 point-to-point wireless bridge system is and what the PDW90 point-to-multipoint wireless system is, so that you'll remember or be introduced the first time to what these products are. In the process of doing that, we're going to see examples of how the PDW wireless products work in a variety of applications, try to clearly show you how they'd be installed, where they go in this sensor to control room setup. And we're going to talk about what products are needed for specific systems, the actual list of bills of materials that will show you what you'd have to buy to build the systems that we're looking at. So to get started on that, let's talk about our PDW30 point-to-point wireless bridge. And I'm going to stop right there for a minute and just note that we call this very specifically a wireless bridge. And what do I mean by that? Well, let's talk about that for a minute. As a wireless bridge, what we mean is I have wires at one point, usually that's, let's say, out in the field, and I want to send that wired signal from the field to my control room or a bus station setup where I've got a centralized location for my tanks, or just get it out of an area that's not accessible. And I want to bring that back into physical wires at that remote location. So what we're doing is we're quite literally bridging that gap of wires, but we're doing it with our wireless signal. So from the perspective of, in this case, the transmitter or the display, they think that this is a fully wired system. They have no idea that there's a wireless system in between here. And the reason I make this point, and this is a really important takeaway from today's presentation, so I urge you to listen well now, is that this allows you to use our systems regardless of what other equipment you are connecting them up to. We don't need to be used with we're not a wireless HART system that needs a wireless HART transmitter. We're not a Profibus system or necessarily, using some kind of existing wireless networks out there. These are designed to bridge wires in already existing systems or in new systems you're building, regardless of what the system, or regardless of what those transmitters and displays may have. If they have a 4 to 20 milliamp signal, they have a discrete output, or they have RS-485 Modbus, then we can, blind to them, bridge those wires to you between those two remote locations. And we'll see some examples of that here in a moment. So let's talk about the PDW30 point-to-point wireless bridge. As we said, it's a wireless bridge system designed to bridge wired signals. And that bridge can be up to 1 mile outdoor line of sight or 500-foot indoor range. One question I often get at this point when I'm talking about the wireless systems is why do we say 500 feet indoors versus 1 mile outdoor line of sight? Well, obviously, outdoor line of sight, you just get a much better signal transmission. We recommend 500 feet indoors because these are going into some pretty hard indoor wireless locations, or locations that are pretty hard to get signals through. It's one thing if you're an office environment where you're going through some real simple drywall and there's not much else going on. But you get into an industrial location and you've got cement walls, steel buildings, you've got all kinds of equipment running inside, and it's noisy equipment, it's rotating equipment, it's motors, it's pumps, it's generators. Those things all make it more difficult for wireless signals to do well. We want to give you a range we feel confident you can achieve without having to do expensive site surveys and such. So we suggest 1 mile outdoors if you have line of sight, and a 500-foot indoor range as being something that in almost every scenario we're going to be able to do. Now, you've already probably read some of these features on the right, so let's start with this first bullet here because I cannot stress this one enough. Plug and play right out of the box. What do I mean when I say that? I mean, if you buy a PDW30, and it is the only PDW30 you have, so the network ID can remain its default network ID. You take this out of the box, you wire up your signals, and you are done. You quite literally do not have to push a button. You do not have to use any software. You do not have to configure anything. You can take a 4 to 20 milliamp signal in on one of these devices, get it out on another one of these devices, and you haven't had to do anything to do that. It just works. That is a big advantage of our wireless systems. They're designed to be simple for the operator, simple for setup. Now, I mentioned a 4 to 20 milliamp signal. Well, what can we actually send? Well, we can send 4 to 20 milliamp signals. And those can go in both directions. So I can have one signal going in one direction from one unit to the other. And then I can have a different 4 to 20 milliamp signal going the opposite direction. Both are 4 to 20 milliamp signals. They're both separate signals, but they can go from the primary to the secondary, from the secondary to the primary. And if you're wondering what I mean by that, I just mean we have a primary side and a secondary side, those two devices. Do all your programming on the primary side, for example, what your digital I/O is going to be, and it just sends that to the secondary. Other than that, and the fact that your Modbus master needs to be on the primary side, there really isn't much of a difference. In addition to a 4 to 20 milliamp input and output on each unit, we have discrete I/O, and that's 4 digital I/O on each device, and you can set that up to be whatever you'd like. So I have 4 digital I/O coming in, I'd have 4 digital I/O going out over here. Or if I wanted to, I could change that up, and I could have it be 2 and 2. Let's say I want to have signals coming back in from my pumps, and those are going to tell me if my pump's actually turned on. Well, great. I might be sending some level floats in one direction, or I might be sending the signals from the pump activation in the other direction. And the last bullet there is that it can have Modbus communications. So both sides have 3-wire RS-485, and that allows you to set this up on a Modbus network so that it provides a wireless bridge of those Modbus signals. And obviously those go in both directions because you're going to be making a master request out to a slave device, and the slave is going to respond back. And we'll look at depth at more of that later, but it's worth going through the fact that these really do have multiple digital I/O on every single one of these blue enclosures. There's not a one-directional system where, like, this is a transmitter that sends a signal out to this receiver which outputs it. Nope, you can go both ways with your signals. If you want to do a site survey, we do have a PDA-10 signal strength survey tool. We'll look at that near the end of the presentation. And though you don't need it for setting up your PDW-30, it's incredibly easy to do it with the buttons if you need any button pushing at all. We do have PDW Manager software, which is free and connects up to USB on your laptop or your PC. And that's used to do some more advanced features usually. If somebody wants to mask some signals or modify their encryption, then great, you can do that on a PDW-30 with the software. Otherwise, I wouldn't even bother using it. You have to set up so little that there's almost no point. It is a backlit dot matrix display. As you can see, it gives you nice clear characters so you can read. This is not a 7-segment display. And this is a critical point. These are 9 to 30 volt DC powered, which means that they're not solar power, they're not battery. You do need to provide 24 volt power in order for these to operate. What specifically is new on these PDW-30 units? Well, we now have a loss of signal output. So we have a special digital output dedicated just to letting your PLC or your SCADA system know if that signal between these two units breaks. We now have a field installable relay module, which will let you turn 2 of those digital outputs into single pole, single throw 5 amp relays. And we'll see that a little bit later on. They now use CapTouch through glass button programming, so you don't need to remove the cover in order to make any modifications you want or to change what's being displayed on the screen. Let's say you want to see jump immediately to what your analog inputs are showing. You can do that just by pushing the buttons on the front. You don't have to wait for it to scroll. Most noticeably, if you are familiar with the original PDW-30, you're going to notice this larger IP68 enclosure. We'll see it compared to the smaller one later, but we went with a bigger box because it just means we can make it more rugged. It means that you have more room for wiring, and it solves a lot of the problems with the original version of the product. And with that new enclosure, we now have an improved operating temperature range going down to -55. So for those of you who may be from Canada up north, that is, we will operate at -55. The display may fail. The display is going to probably go dark on you. It'll come back as it warms up, but it will continue to transmit wirelessly. The enclosure will remain structurally sound down to -55 C. Here's a nice look at some of those features, some old, some new, of the design of the PDW-30's hardware. We've made a lot of improvements to the enclosure. Not only is it bigger, but it's got loops in there for your stainless steel tags. It's got a hole in the lid so that not only can you have your locking screw to tool secure it, but you can actually put a loop through those two and use your lead seal on there to keep these closed and tamper-free. Got a better display on there, the CapTouch buttons. The antenna is now more rugged than it was before. We've got better flanges now for pipe or wall mounting, so you have a wider range of pipes you can connect it to, but still have them there for convenience on how to mount this. And of course, one thing I haven't mentioned yet, but you probably have noticed, is that we have a stainless steel version of the enclosure now. So if you are putting these in salty environments or places with harsh chemicals, you can get it with a stainless steel housing. If you're wondering how you make your connections to these, there are 2 conduit entries on the side of each enclosure. Those are 3/4 inch NPG conduit connections, so you can bring in whatever wires you want for whatever signals you're trying to transmit. And to really understand the way that new enclosure impacts things, it's nice to see them side by side. You can see the old enclosure was smaller, but also its electronics were more susceptible to damage. Because of that tiny enclosure, you're fitting a lot of wires in there. You're trying to dig your hands around in there to pull out connectors. You've got torque coming in potentially from that antenna cable you're bringing in. Lots of reasons why this new design is a lot better, and a real big one is just the ruggedness of the electronics themselves. Now we put them inside a fully enclosed electronics module. You can see that the wireless connection is made right in the center of that, and it's embedded within that plastic shell, so you're not going to have issues with that antenna snapping off or causing that board to lift. There's no exposed circuit boards at all, so you're not going to get any issues with contamination or damaged components as you're working with it. And we have a more securely attached antenna, which itself is also more rugged. To pull this in and out, you no longer need any tools, not even thumb screws you could potentially lose. You just push and pull it, and there's a snap feature there that just locks your display down. And if you look inside there, you'll actually see the 2-relay expansion board, which you show here over on the right. This installs right down on the bottom of that enclosure and allows you to bring in 2 of your digital outputs to turn them into Form A 5-amp relays. And that can be added at any time. It can be put on one side or the other. It's a really convenient way to get real mechanical relays out there if you want to use them to drive pumps or lights and horns or things where you just don't think a digital output is called for, or if perhaps you can't handle the current through just a digital output. We've got that aluminum or stainless steel option now. CapTouch through glass programming. And with that, let's talk about a couple of wireless applications. Although actually, before we get into a couple of sample applications here, I do have some questions for you, because this is the point of the presentation where I could really tailor it a little bit to who is in the audience. And it would be nice to know a little bit more about you, what you do, what kind of industry you're in. And so I'm going to go ahead and launch a poll here. And if you could just give me a sense of what it is you do and how familiar you are with the previous version of our PDW wireless systems, I may add or drop a couple of slides as we go here to try to more appropriately address it for who's in the audience. And it looks like we got some answers coming in. I appreciate that. I'll give you another 20 seconds to fill that out. Looking like we've got a lot of our distributor salespeople here, which is not surprising, both inside and outside. But we've also got some systems engineers. We've got some plant INC techs. So a pretty diverse group, about half of which is our distribution channel. So I will tailor the rest of this discussion to try to do that. Interestingly, it doesn't look like anybody considers themselves an expert on the PDW wireless systems, though there are people out there who have had experience with it. And if you're curious, I'm going to go ahead and share those results just so you can take a look at them. As you can see, a lot of our distributors are present, but we've got some systems designers and plant INC techs as well. A lot of you did not take the poll, but I'm going to assume that this is a representative group. Pardon me. Let's take a look at a fairly basic application for the PDW-30 units. Here I've got wireless tank level monitoring going on. And I've got this water tank out in the field, and somewhere remotely, I'd like to bring it into my PLC, but I'd also like to see it displayed. I'd like to take a look at that value at a remote location. Now that could be just on the other side of the road from this tank, or it could be over at a centralized location where I'm bringing all my tank displays in. There's lots of ways you could set it up, but we keep it fairly vague here, just to keep it simple. So I've got my 4 to 20 milliamp level transmitter, and that's outputting a 4 to 20 milliamp value that's going to go into my secondary unit of the PDW-30. That gets wirelessly transmitted through the magic of science over to my PDW-30 primary unit, where it's going to come out as a 4 to 20 milliamp signal, which is going to power up my loop power display here and allow me to scale that value. Now, I want it in the PLC as well to know if this system goes down. So I'm going to bring my loss of signal digital output over here to my PLC so I can flag people in the control room if this link is lost. I could stop there. I've seen plenty of applications where actually that is all they're trying to do. However, just to show you a little more of the capabilities here, we're going to expand on that a little bit. Now what we're going to do is we're going to take the relays out of our loop power meter. Precision Digital's loop power meters can actually have solid state relays in them. So we're going to take those relays, bring them back into my PDW30 primary. Actually, I'm going to change the color so we can see that these signals are going in a different direction. Each one of those two relay outputs then gets transmitted wirelessly, where it can come out as either digital outputs or with the relay module relays. And we're going to use those contacts to turn on some high alarm and low alarm lights. So now I've got my 4 to 20 going in one direction wirelessly. I'm bringing back from alarm states, and I'm using those, to trigger my high alarm and low alarm LEDs I've mounted out in the field. To do that, what do I need to buy? Well, I need one pair of the PDW30 GPAL pair. So this is one line item, quantity one, but it gives you both a primary and a secondary. They're all synced up and ready to go out of the box. Then I got one of our relay modules to put out in the field to drive my LEDs drive my lights for my high alarm and my low alarm. It means I'm going to get two red light and horn combo units so that I can have those to mount out there. And I'm going to get one of those PD6602 loop power meters with the two solid state relays, which are going to be the relays that drive those digital inputs and outputs that go to the relay module, which turn on the red lights. So that whole system is available from Precision Digital, minus the PLC, of course. And it's a nice way to avoid having to wire up what would otherwise be lights and a couple of lights, a 4 to 20 milliamp coming back from the tank, and now instead I just drop these there and I'm done. If we look at a little bit more of a complicated system here, this time, same deal, we've got a 4 to 20 coming in, that 4 to 20 goes wireless, comes back out as a 4 to 20 to a loop power meter. But now, instead of just setting off some lights and horns out in the field, I actually want to be able to give manual feedback to a valve positioner that's going to allow me to fill that tank. So here we've got our PD460 valve positioner, which just uses the dial to set a 4 to 20 milliamp output. And we're going to take that 4 to 20 output and bring it into my secondary unit, which is then going to wirelessly transmit it out to the field, where it'll come back out as a 4 to 20 milliamp output and go to the valve positioner. So now I've got bidirectional 4 to 20 milliamp outputs, one coming in from the field, one going out to the field. Similar setup the last time. To actually build that system, I need one pair. And then in this case, I'm going to do two light and horns because sorry, give me one moment here. I guess I don't have those on the picture, but I probably do want those, so I could use lights and horns. My 6602, which is my loop power meter that I'm using, just display what those numbers are in this case, here. And then a PD460 panel mount 4 to 20 milliamp valve positioner. Now, I already have two of you asking, and I'll pause in a minute for questions at the end of the PDW30 section, but I already have two of you asking about repeaters. And so here you go. You can actually get repeaters. We recommend you don't go with more than 4 repeaters to any system, but you can certainly add repeaters to extend your range. A repeater will add 1 hop worth of distance, where 1 hop is that 1 mile, 500-foot indoor range. And so here we have the same system we saw earlier, where I'm bringing in my 4 to 20, but now it wirelessly will go through the repeater to get to the other side and then become a 4 to 20 out again. An important note here, the repeaters don't do anything other than be a repeater. So there's no I/O coming in or out of this thing. That doesn't exist. It is just a repeater for the wireless signal. And why would you use that? Well, it could be range. It could be I've got a big, huge tank right here, and my signals are having trouble getting through it. It's not a bad idea to add them if you're at the far limits of your range, but generally, I find that they are just not needed for applications. A lot of these are not going all that far, but if you do need it, we have one. So in this case, it's the exact same system as before, the PDW pair, relay module, the lights, the loop power meter. Now, however, I've added this PDW GPAL REP, the repeater, to that system. So I get the pair, which comes with my two units, my primary and my secondary unit, and then the REP comes with one of those repeaters. With that, I'm going to pause for a moment, answer a couple of questions from folks on the PDW 30s. I'm going to hold the PDW 90 questions because we're about to talk about those. Looks like I've got a question here from Carlos. Carlos wants to know, is it possible to solar power the units? And then he addressed the fact he does know they're 24-volt powered. It's possible. Precision Digital does not provide a solar power solution. However, I have worked a number of applications I can think of where people have built their own solar solutions. So if that's something you are familiar with and you can source or you know how to implement, there's no reason you couldn't power these off 24-volt solar systems. We just designed them to be 24-volt powered, and then how you get that power is sort of on you. Similarly, I've got a question from Don, who's asking, can I battery power these if I provide the battery? Well, the answer again is yes, although I'll tell you a solar system is going to have more success than a battery power system. We designed these in order to be able to communicate as quickly as possible with each other because they are a wireless bridge product. We did not design these to communicate sparingly in order to conserve battery power. So you probably could use battery power to do it, but personally, I would not suggest that. I would suggest, if at all possible, that you just wire them up to some kind of 24-volt rail, or lacking that, you design an appropriate solar power system in order to run these. Rodney's asked the question, what is typical delivery on these products? That's a great question. So some of these we have in stock, and some of the components we have in stock. I think at this point I would say we have most. However, if we don't have stock on these, then you'd be able to get your delivery, obviously depending on quantity, in up to 5 business days. If you were to check our website right now, for example, you'd see that we've got 10 of our PDW30 aluminum pairs in stock right now. If you decided to order 11, then we're asking you for 5 days to build up the excess and get it out to you. Worth noting, our stock and availability is all available on our website, predig.com, and that is actual information. That is looking right into our ERP system, pulling out the stock that's on the shelf, calculating lead times based on PO deliveries or whatever if there are PO deliveries needed. Most of the time there isn't. Or then putting it through our production system and trying to say, okay, what would we be comfortable with for this to get through our production system if we had to build something for you for that order. So if you have questions on price and delivery, check the website. It's some great data up there that everybody can see. Doyle is asking about our demo units, and we certainly do have demo units available. The demo unit that is just being released out of engineering now has a pair of our wireless survey tools, which you'll see in a moment, and then a sample field unit so that you can hold that, see that, turn it on, see what it looks like. But then if you just want to know, hey, is this going to work, then it comes with a survey kit with it so that you can actually just carry that around easily. And that is battery powered, so you don't have to provide power at that time. You just want to basically do a site survey and see what the field units look like. That is what the demo kit for this product looks like. Excuse me one moment. Yep. And then lastly, I have a question from Heather asking about, and I'm going to go back a couple of slides so that I can detail that, asking about the installation of the relay module. Her question is, how exactly does the relay module install? It can be installed after the fact. Is it just a couple of wires, or is there more to it? And no, the answer is it's just a couple of wires. Take the digital outputs that are underneath this top module, wire those digital outputs into this plug here on the relay module, and then when those digital outputs trigger, these relays trigger. And all you have to do to actually install it is, beyond making that wiring connection, as you see there's 4 screw holes here. So you just take this fully enclosed plastic module, drop it into the bottom of the enclosure, put your 4 screws in, and you're done. So very easy. Can be installed after the fact, but cannot be installed in the older units. If you have the small enclosures, then obviously this is not going to work. I have a few other questions. I think we've got time to cover them. So let's see. David is asking, can the wireless signal get through a building wall? Well, it depends on the building wall. Usually, yes, just fine. It's going to impact your range, but I've seen all kinds of cases where they're going through building walls without a problem. Now, if you have a large steel building with multiple walls inside, obviously it's all grounded and you're trying to get the signal out of there, you're going to really severely impact your range, but I have seen it done. That is one reason why you might want to engage a survey kit. It's another reason why we tell people it's 500 foot indoors, because we want to take into account that these are going through some pretty difficult environments. But yes, they do pretty regularly go through walls. If it's just an office environment, for example, it'll go through our whole building here at Precision Digital. You know, we don't do any kind of heavy industrial work, and we're a pretty simple building. So it'll go through the entire office here all the way back to the shipping dock, no problem whatsoever. And then Lynn is asking, which type of communications going between each PW30? So I didn't get into too much of that because that goes over a lot of people's heads. But if you are curious about that, it is a 900 megahertz spread spectrum frequency hopping signal. So you're generally frequency hopping somewhere around 900 megahertz, you know, plus or minus 20 megahertz. And it is an encrypted signal as well. This is a proprietary unit that's using an encrypted 900 megahertz signal. So it's not wireless HART, it's not Wi-Fi, it is its own communication protocol in the 900 megahertz band. With that, I'm going to hold on the PDW90 related questions, and we're going to jump right into that. Let me pause at this screen just for one more moment to give you the brief overview of what a PDW90 is. Well, the PDW90 is a point-to-multipoint system. And that means exactly what it says. You are going from a point, in this case is our base station, and you are going out to multiple points in the field, which will each have a field unit installed at them. So rather than just going from a primary to a secondary where they both look like that blue or stainless steel field unit, now you are going from a separate device called a base station, and you are going out to various field units at different locations. And a nice, easy way for us to represent that is just to have them all be in a tank farm. And of course, those signals do come back to the base station. So what are the features of our PDW90? Well, it consists of a base station and field units, and there are 3 base stations shown here because they're available in 3 different sizes. You may choose to populate them internally with a number of modules, and so we size them based on how many individual module slots that you want to have in your base station. Same range, 1 mile, 500 foot indoors. And the field units are just like the PDW30 units. So they have a 4 to 20 milliamp input, a 4 to 20 milliamp output, 4 discrete I/O, and Modbus RS485. The base station, however, you build up your I/O. So it's got modules for 4 to 20 milliamp inputs, 4 to 20 milliamp outputs, relays, and digital I/O. And it comes with RS485 standard. Our PDA10 signal strength survey tool works for this as well. It's the same wireless module, same communication type. The PDW Manager software, the free USB software, is required to set this up. There is some mapping you have to do to tell it which modules at the base station map to which of your field units. And so that does have to be done on the software. It's not particularly difficult, but you do need the software to do it. And it is worth knowing that all these PCBs are conformally coated, so you get dust and humidity protection on these, because we've just found that that is a nice way to help these last and to protect them from damage. Lastly, once again, the PDW90 is a 9 to 30 volt powered unit, so you want that 24 volt supply. You can provide your own solar. You're probably not going to battery power it. It really is designed to be line powered. What are the new features on these units, if you're familiar with our old PDW90s? Well, now we will do up to 32 4 to 20 milliamp signals. We now can connect up to 32 individual field units from a single base station. And the base station can have 16 cards, each of which would have 2 analog outputs on them. And so that means I can, if all I'm doing is connecting up to a 4 to 20 milliamp signal, I can take 32 inputs in 32 field units and get 32 4 to 20 milliamp outputs from my base station. If that sounds confusing, we'll talk about it more in a second. We've got different sizes of base stations for 2, 6, or 16 field installable I/O modules. We've got that loss of signal digital output added, the stainless steel field units, and that minus 55 operating temperature range, just like on the PDW 30s. Looking at those features up close, this is a completely new electronics redesign. We've once again enclosed all of the electronics, so everything is now inside plastic electronics modules so that you don't have any exposed PCBs. When you buy a module, which we'll see in a minute, but when you buy a module, you get the plastic module as well as the plug connector for it. So you populate these slots for modules with whatever kind of I/O you'd like. This all goes inside of a rugged NEMA 4X plastic box. And the field unit has all the same features of the PDW 30 we just looked at. So once again, you've got your 3 sizes of base station. Pick the one that has the I/O slots that you need. Field units, stainless steel, just like the PDW 30. The PDW manager connects right from the base station to your laptop or to your desktop with a USB cable. You do need to use that for programming. And if you need to cycle through your screens in the field or make any changes to the field units, you can do that with CapTouch buttons. You do not have to remove the glass, remove the lid. The new field module base station, the new base station modules are much better than the old ones. A lot easier to install. You just snap them in, put a couple screws in, and put your plug into the connector here. Everything is protected. You're not going to damage your electronics. Looks nice, and you don't have to worry about wires hitting things they shouldn't. We also have that relay module for the field units. So if you wanted to, say, take in a digital input in a base station and then send it out to a field unit to have it output as relays, you can certainly do that. Let's take a look at what a PDW 90 application would look like. And you may recognize most of this from a previously discussed application, because we're just going to take that, we're going to double it, and make it a PDW 90 system. So once again, I've got now 2 tanks in the field where I have level transmitters, and those level transmitters are each providing a 4 to 20 milliamp input into their field module, field unit. Those then wirelessly send their signals back to a single base station. In this case, we're using a 2-module base station. Apologize, I keep sneezing on you folks. Hopefully you're not catching too much of that audio. Try my best to mute it. And we're using those 2 modules to provide 2 4 to 20 milliamp outs, so 2 times analog outputs, that's 1 module. And then we've got 4 times digital I/O, and that's our other module. So we have our 2 4 to 20 milliamp outputs that are running 2 loop power meters. Those 2 loop power meters each have 2 relays that are bringing those back into our digital I/O on the base station and are mapped to output them to the field units where they will control the high and low alarms at each tank. So it's the same thing that we had going on before, but now I've got a duplicate system, so I've got 2 of those setups, but we're driving it all with just 1 base station doing all of the I/O. What does it look like if I want to build that application? Well, it's a little different. Now I need to get a base station. So I went out and I got this 2 I/O slot base station. Then I need my I/O modules. So I've got an dual analog output module and a 4 digital I/O module. In the field, I'm going to want 2 field units, so 2 aluminum field units. And I'm going to want a relay module for each one of those field units to run my high and low alarm lights. For the accessories, I'm obviously going to buy the lights and horns, and then I've got my 2 loop power displays. So the key takeaway on this page is that now, because I'm using a PDW 90, I'm building it with components. It's no longer just one line item, here's your PDW 30, works out of the box. Now I'm going to build my more complicated system. I'll say, here's my base station and the cards I need. Here's however many field units I'm connecting up to, and relays if they need them. You take this to an extreme, and you get a situation like this one, where now I've got my 16 module base station, which can all contain 2 times analog output cards, which is going to get me to my 32 analog outputs, or 4 to 20 signals. And so I could have 32 tanks, each sending a 4 to 20 milliamp signal into this field unit. The field unit goes back to the base station, times 32. And then if I want to keep it all in the world of 4 to 20 milliamps, I can have 32 pairs of wires going from my field unit into my PLC. Now, some of you are asking, why would I ever do that? Why wouldn't I use Modbus? And you'll see that in a minute. But keeping it in the world of analog outputs and inputs here, what would I do? I'd get my 16 base station, my 16 module base station. Then I'd buy 16 of those dual analog output cards, or modules, I should say. And then I would get 32 field units, one for each one of those tanks. Hopefully that is fairly straightforward. We have found that most people do get their ordering right, which is nice to see. But you're thinking to yourself, 32 wired 4 to 20s seems a little excessive. Well, you're absolutely right when you have Modbus available. And Modbus will let you do a lot of the same things we were doing earlier, but with a lot less wires. So let's talk about what that might look like with a fairly simple Modbus application here. In this situation, I have Modbus level transmitters. So rather than going out as a 4 to 20, I'm going to connect up my 3-wire 485 between each one of my field units and its associated Modbus level transmitter. Those are all wirelessly bridged to the field unit, to the base station, which is connected up via RS-485 to our Consolidator Plus, which is equipped with our Modbus client package. What does all that do? Well, that means that when our Consolidator Plus, which is going to be the source for the display and the control of this system, wants to read a value, it is going to make a request on the 485 line of one of these devices. That signal is going to be sent out to all of our field units, and it's going to be sent down that line to those Modbus level transmitters. Whatever one's the correct one, whatever one actually matches up to what it's trying to read. So it's going to pull out and say, hey, give me device 1, address 1. Well, if you're device 1, you're going to respond with address 1. So if that's tank 1, it's going to send its signal back to the field unit. It'll send its signal back to the base station. It'll send its signal back to the consolidator. And so if I can just pause there for a minute, as the consolidator is now going to display that level from tank 1, keep in mind that from the consolidator's perspective, it doesn't know anything past that point right here. All it knows is it's wired on RS-485, and it got a signal back from when it asked for the request. It has no idea that any of these wireless bridges are happening. And that's great because it means you can put these into existing Modbus networks. If you find wires that break or you need to add a Modbus extension for your 485, you can put this into an existing network and you don't have to change anything. You don't have to reprogram your PLC to know, oh, well, yeah, we're going wireless to get to that other yard over here where there's 4 more tanks. It has no clue that's wireless. It just sends it out on its wires, and it gets it back on its wires. Now, something else we have done here, which is rather tricky, or not tricky, which is rather clever, is we have added our PD6730X tank side indicators here. That's not really related to our wireless system, but it is good practice to always have a display next to the tank to tell people out in the yard what's going on with it. And what our 6730X does is it's a Modbus snooper, or in other words, it's a Modbus packet sniffer. So those can be programmed so that every time that request is made of the transmitter, and then that transmitter responds back, Well, that's also going to be on the line with the 6730X. It's going to see that response happening. It's going to grab that and display it locally. But again, in that case, the consolidator nor the transmitter in the field even know that it's there. It's just displaying a value that it sees captured on the network. So now I've got 3 field transmitters, 3 field units for the wireless system, and 3 in the field next to the tank site indicators, all installed at each tank. And then back at the centralized location where I want to see all this information, I got 1 small base station and a consolidator plus running this Modbus system. Minor note to keep in mind for those of you who do work with Modbus, much like your Modbus master or your client needs to be connected to the primary of a PDW30 pair, your Modbus master needs to be connected to the base station. And if you're wondering why, it has to do with the fact that Modbus is a complicated protocol. And so to send it wirelessly successfully, we've got some added work we've got to do on our end to sort of code up those packets properly, transmit them, get them back, and reassemble them. And that's just easier to do when you know that your master is connected up to a specific device. So what's in that system we just looked at? Well, we've got our base station. It's just 2 I/O slots. Not even actually using any I/O slots here. These are both empty, but I need a base station for its RS-485 connection. Then we've got our 3 field units. Don't need any relay modules here. And we're using a Consolidator Plus with its Modbus Master feature add-on. And we're putting 3 6730X units out there in the field next to each tank for local indication. You take that to its natural conclusion at 32 units, and you see it's a lot easier system to connect. I still have 1 field unit connected up to each one of my level transmitters. However, now, once those signals come back to my base station, I just have to wire 3 wires between my base station and my Consolidator Plus. My base station can even be smaller, and I don't have to buy any I/O cards for it. So if you're going to do large systems, I always encourage folks to go with Modbus because you're just going to find the programming or you're going to find the wiring easier, and the programming isn't really all that much more complicated. In that case, we've now reduced down our 32 wireless points to a base station with just 2 I/O slots, not that I'm actually using any, 32 field units, and then in this case, we've got the consolidator and our Modbus master package. So what all this wireless stuff can look like in the field is a situation like this one, where we're looking at a municipality in New York State that's got a wastewater plant. And they went with a PDW 90 system because they had 8 points they wanted to monitor. They had 3 points down here at the sedimentation tanks. They got a digester that they want to measure. And they've got these chemical storage buildings up here where they also had 3 signals they wanted to bring back. And all of that's got to go to the control room, which is here in sort of a centralized location, but they've got to go in all sorts of directions in order to connect up to these. And it'd be a heck of a wiring project to try to run wires to all these different locations. So they went with our wireless system. It was very easy for them to mount the field units out in the field because those enclosures are designed in so many ways that you can just bolt them on to structural beams or right on the side of your building, mount them on a plank of wood if you have to. They're rugged, they're weatherproof, so they mounted them up high, they got their line of sight, put them right outdoors. 24 volts was available all over this facility. You know, these weren't going anywhere where there was literally no power, so very easy for them to get the power they need to run them. And you'll note they used their standard antennas. We didn't have to do anything fancy with Yagis or anything like that. The range worked out for them. Now, if we were installing this today, I would note to them that we do have stainless steel field units. Those might be handy for the chemical storage sheds, but we did at the time, so they went with aluminum on everything. And here's their base station. Their antenna is connected up right there. You see it's just sort of crooked sideways so that you can see it right through the window. And then they take all those 4-20s out. So the 16 wires, 8 4-20 pair coming out of here and going off to their control system where they see all those values. What's nice about this is they want to expand it in the future. When they decide to do that, that's going to be really easy because they just buy a new field unit, they buy a new I/O module, they plug them into their existing system. And all said and done, the parts for this installation were roughly $1,000 per point. So this is about a $9,000 system. But it saved them a ton in not just installation costs, but the hassle and sweat of doing that. Let's talk about a few accessories before we wrap up and take some questions. So we do have repeaters for these, much like the PDW 30s. They're available in aluminum and stainless. And the idea, again, of a repeater is extends at 1 hop. So if you have 1 mile, well, you can get an additional 1 mile hop by putting the repeater in the middle of those 2 units. No other I/O out of the repeaters. We've got a variety of different mounting brackets for these. We've got U-bolts that we'll put it on a pipe if you're just using like a PVC pipe, or even if some of these offset pipe mounting kits like you see here, which are useful if you have a metal pipe because you don't want your antenna to just be right up against a big grounded metal pole. That relay module will work with either side of the PDW 30 or in the PDW 90 field units. It's a great way to turn these into control elements if you want to be able to control some pumps, some lights, some horns, things like that out in the field. And I mentioned the survey kit a few times. That's what this is here. This is the survey kit. The idea behind this is that it's the same wireless transmission equipment, but in a handy battery-powered, site-surveyable toolkit. So one person can do this. You leave this target device at one point, and then you walk around with the handheld unit, and it reads out on it what your percent connection is. You know, if you have a good connection, bad connection, high, low, reads it out as a 0 to 10, gives you information in various ways to know if you're going to be okay installing the system right there. There is some troubleshooting you can do with this as well. If you're asking yourself, what do all these buttons do? It can find the closest field unit, try to figure out why you're not getting your signal through that way with some surveying. But 99% of the time, this is just used to survey a site before buying the units so that you'll know if it works. These are battery powered. So if your battery dies, you just go to CVS, buy some batteries, put some more in. We've got some Yagi antennas as well. We've got a 6 dB and a 9 dB Yagi antenna available. They come all fully assembled, ready to go. And if you're asking how the Yagi antennas would hook up, well, we offer you a 20 or 40-foot extension cable that goes to the N-type connector that's on the Yagi antenna. So you connect up your N-type, you go through your 20 or 40 feet, and then just come into your wireless unit from there. And the new, more rugged electronics module is going to make sure that if you have that cable like that, that's not going to twist or pull or break off any of the parts of that wireless module in there. The obvious question you're going to have is, well, what range increase do I get out of using this Yagi antenna? I'm going from a 3 dB antenna to a 6 dB or a 9 dB. That's got to be significant range increases, right? Well, the answer is yes. But it's very hard to predict what that range is actually going to be. My recommendation with these is always that you use them if you are a little out of range. I'm not going to feel comfortable giving you some number where I say, oh, great, now you can go up to 3 miles. I would not suggest that. These are a nice device when you're on the edge of what we're capable of and you want to do something more. But it is a hard thing to do to predict true ranges like that. One thing I will note with Yagi antennas is keep in mind they are very directional. So, for example, this would not have worked on that water site that we looked at earlier in that application example where they wanted to send some signals north and some signals south. There'd be no way to aim the base station's Yagi antenna appropriately. They didn't need it there. That kind of range doesn't require it. But if they did, you have to keep in mind that Yagis are directional antennas. I think you have, don't quote me on this, but about a 15-degree angle. So you do want to keep it at a location where the two can face each other and not trying to be going all over the place to a bunch of different field units. This is what your base station modules look like. They also come with the small green connector that's depluggable that you bring your wires to drop on. There's a dual analog input module, so 2 analog inputs into your base station, which would become analog outputs in the field. There's the dual analog output module, so you take your analog inputs into your field units and they output at the base station. For digital I/O, like all the digital I/O, it's mappable to be an input or an output. You can figure that, so 4 ins or 4 outs or 3 and 1 or 2 and 2, whatever you want it to be. And we have a dual relay output module, so if the I/O outputs, if those digital outputs are not going to be able to carry enough current or handle enough voltage, we've got mechanical relay modules you can plug in there to drive heavier loads. With that, I'm going to field whatever questions are left here. We've got a couple on the PDW 90. For the record, if I do not get to your question, I apologize for that. We are running out of time here, so that very well might be the case. We'll do some follow-up after this webinar the next few days, so if you had a question you didn't get an answer to, hopefully we'll reach back out to you and get that question answered. If you choose to leave us now, or if you stick around for the couple of questions we have time left for, please fill out the survey at the end. I'd appreciate you taking that 1 minute to do that, because they do help us plan better presentations in the future. That having been said, let's see what other questions we have here. Joe's asking, is the 900 megahertz licensed? I believe so. One of the nice things about this system is that we are not reinventing the wheel. We have designed it to use a 900 megahertz proprietary wireless module from Digi, which you may never have heard of, but Digi is sort of the industry leader in proprietary communications like these. And so they get all the FCC marks and things like that on their modules. Then we buy the modules and we interface our products to them, write the code that talks between our microcontroller and their wireless handler. And so thankfully, we did not have to totally navigate that license transmission bands, FCC approvals world. They did that for us just by virtue of the fact that we're using their product within ours. And so that's my way of saying I am confident that these have the licenses or the bands and operate in a way that is appropriately legal and correct. But I can say that because we didn't have to learn it. We've certainly learned a lot about it now, but when it's your first wireless offering, you don't want to make those mistakes. So we went to the experts to do that for us. Steve is asking an obvious question, which I'm surprised took this long to show up, which is, are these units hazardous area approved? I mean, I understand why you'd ask. They certainly look like it. They are indeed going in enclosures that could be explosion proof. However, no, these are not hazardous area products. They are just for safe areas. There may come a time 6 to 12 months from now where they are hazardous area approved, but they are not at the moment. Right now, it is just a safe area only product. And with that, folks, it is almost 3 o'clock, so I'm afraid I do not have time for other questions. There are still some in here, so we will try to get back to you on those. I appreciate the participation. I'm sorry I couldn't get back to you on those questions with some answers. But I hope you did learn something here today and it was a valuable use of your time. Once again, if it was, tell me so in the survey. If it wasn't, the survey is a great place to complain. So I will see you all hopefully in our next presentation. Enjoy the rest of your week. Thank you.